Welcome back to our series on probability theory. I'm Mark Ledbetter. This is lecture video 40, part B. We are finishing up the bivariate normal distribution. So up to this point, we have discussed the joint PDF of the bivariate normal distribution. We have derived one of the two marginal distributions, and we have derived one of the two conditional distributions. We talked about properties, and we also discussed the theorem that if x and y are bivariate normally distributed, mu x, mu y, sigma x, sigma y, rho, then rho equals to 0 if and only if. So rho equals to 0 implies that x and y are independent, and x and y being independent imply that rho is equal to 0. We have the general form of the theorem that says that if this is true for, this is only bivariate normal, only, and then for all, if x and y are independent, then rho is equal to 0, but rho equals to 0 does not imply x and y are independent. So the normal distribution is the special case where rho equals to 0 does imply independence. This is important. We will certainly need this next semester. We may need it later this semester. I don't remember. All right. So we talked about this theorem. Let's now do an example and make sure that we understand what we're doing. So this is example, this is 5.2-2 example, and X is the GPA from high school, and Y is the GPA in the first year of college. And it says assume that X and Y have a bivariate normal distribution with mean X 2.9, the mean of Y 2.4, the standard deviation of x, 0.4, standard deviation of y, 0.5, and rho is 0.6. You could encounter a problem that said bivariate normal, and then it would be 2.9, 2.4, 0.4, 0.5, 0.6. Make sure that you go in this order, okay? So that order. I will try not to give you something like that, but if you do see it, then make sure that you go in the proper order. So we want to find the probability that y is between 2.1 and 3.3. Now, just like we did with the regular normal distribution, this is the normal because remember, this is y. We're going to take y and we are going to convert it or transform it to z. And so z is equal to y minus mu y over sigma y. Okay? And so we have, this is y here, the value that we're given of y, minus the mean of y. The mean of y is 2.4. So this is mu of y, and 0.5 is sigma of y. So make sure you get the right sigma. And then I've skipped a little step here where I did the subtraction and just said that's going to be z. We know that y minus mu of y over sigma y is going to be z. And then I did the same to 3.3. I subtract the mean, divide by the standard deviation. And so when you work this out, it nicely becomes 0.60 and 1.80. And so this is phi of 1.8 minus phi of negative 0.6. Let's look at our table, and I think it's important to review our table here to make sure that you understand how to do this, because these tables are not like the tables that you would have used if you took Stat 222. And not everyone had to take Stat 222. So here is the first part. And so this is for z greater than 0. So these are positive z. In this table, z is greater than or equal to 0. So if I look at my thing here, I need 1.80. 1.80 is going to be the first one. So let's look at the table for 1.80. And that is 0 is the second decimal place is the first column. So the second decimal place is across the top. So for 0 as the second decimal place, we go to the first column. So that's 0.9641, which is what we have put here. And then we need phi of negative 0.6. So there are no negatives here. But it says that phi of negative z is equal to 1 minus this. So I can find phi of 0.6 and subtract it from 1. That's one way to do this. Or I can go to the second table, and it says that this is the critical value. So it says that the area above the critical value, see the subscript here, is the area that's above it. Okay, so it's also true that the probability that z is greater than z, little z, is equal to phi of negative z. So if I find 1 minus phi of 0.6, this is equal to phi of negative 0.6. So I look down here and I find that this value is 0.2743. Now, obviously, if you want to use the first table, you can, if that makes it easier for you. But I get the number directly from this table, 2743. And so I plug in 2743, and I get 0.6898. Now, this is only for the marginal. This was for the marginal distribution of y. Please do not be fooled into thinking that you will get the same answer when you do the conditional. The only way you will get the same answer is if rho is equal to 0. So if rho equals to 0, then, only then, will this be the same answer. Because if y and x are independent, then this value of x doesn't matter. Y is independent of x. If it's not independent, and by the way, we know that rho, whoops, still have my eraser on. We know that rho, let me clean this up after all, is not 0. Rho is 0.6. So this is not going to be the same answer. It's going to be different. So please remember that. So now I know that y given x equals 3.2, is a normal. And I've written out, and I want you to do this. I want you to write out what it is in general terms. So this is the general formula, and this is the specific formula. So the general formula is I've got mu y plus rho, sigma y over sigma x, x minus mu x, and the variance is sigma y squared times 1 minus rho squared. Write that out and then plug in the values for this section. This will hopefully help you keep from making mistakes. It does me at least. So mu of y was 2.4. Rho is 0.6. Sigma y was 0.5. Sigma x 0.4. X is 3.2. And then mu of x was 2.9. I got all of these from up here, right? And then I need the variance. And the variance is 0.5. That's sigma y squared. So that's going to be 0.5 squared. Don't forget to square that because you're only given sigma, not sigma squared. And then 1 minus rho squared. So don't forget to square 0.6 here as well. All right. And so when I work this out, I get 2.625 and 0.16. So I also want to point out to you that if I want sigma of y given x equals 3.2, I take the square root of sigma squared. This is sigma squared of y given x equals 3.2. It's the square. So square root of this is 0.4. Okay? So it's a nice number. And now that I have the distribution of y given x, that's got to be your first step here, okay, is to find that. Once you've found that, then you can plug in to here. So please be specific, do not be sloppy, so that you are communicating to me that you understand what you're doing. So do not leave this part off. That's what I'm asking, okay? So make sure you put that part in there. And then we're going to do our transformation, our z transformation. So we have to take, so we're taking, this is going to be y given x equals 3.2 minus mu of y given x equals 3.2 divided by sigma of y given x equals 3. Something happened with delay there, 3.2, okay? And so here is sigma 3 of x equal, y given x equals 3.2. So that goes on the bottom. And then our mu, this is mu of y given x equals 3.2, okay? And so we plug that in, 2.1 minus that, divided by 0.4. The center becomes z, and then 3.3 minus 2.625, 0.4, and then again keep this at this point. Solve for these two numbers, and you're going to get negative 1.3125 and 1.6875. Again, keep this. Keep the conditional until you change to phi. Once you change to phi, I don't want to mess it up and make it be tedious. It'd be too much. So once you get to here, you can change to phi. So this is going to be phi, and we need to round this to 2 decimal places. That's what's in our table. So this becomes 1.69, and this becomes negative 1.31. And so I can look up 1.69 in the table, the first part. So 1.69. I know that 9 is the last one. Whoops. Okay. So 1.69, that's going to be 0.9545. And so 0.9545. And that's what we've written here. And then I need phi of negative 1.34. So I go to the second part of the table and look up 1.34. 1, 2, 3, 4. This is 0. So 0, 1, 2, 3, 4, 0.0901, negative 3.1. I'm sorry. I looked up 3.4. I don't want 3.4. I want negative 1.31. So I looked up the wrong thing. So negative 1.31 will be 0.0951. So 1.3, 0.0951. Subtract those and we get 0.8594. This is quite different than 0.6898, isn't it? Very different. So you can see that these are some of the types of problems that you will encounter in this section. So I hope that helps you understand what we're doing. Please make sure that you're careful and that you understand whether you're doing just the marginal or if you're doing the conditional. And unless rho is equal to 0, they will not be the same answers. Okay, so that's it for this video and this section on the bivariate normal distribution. Please don't forget to scan and upload your class notes or lecture notes before midnight of the date listed in the course calendar. If you have questions, please come to my virtual office hours. I'm happy to help you. If you can't make it to the next virtual office hours before you need help, then by all means email me, but email me a picture of the problem so I know which problem you're working on, and a picture of your work so I can see how you're approaching the problem, and then that will help me help you much faster and much more efficiently. So please stay safe and take care of yourself. We hope to see you next time.